2018 April. Question 4. Figure 2 on the next page shows a steel beam loaded with 2 point loads. Point loads give this forces again. The 4, 1, and 5 is 2, and then and 2 uniformly distributed load. Uniformly distributed load KUDL is 7 kilonewton per meter and 2,5 kilonewton per meter. The beam has a 1,5 overhang on the right hand side. On the right hand side, we multiply 1,5 on the right side, 1. Yeah, there's 1,5 from F to B, 1,5. And then answer each of the following questions with regard to the loaded beam. 4.1, calculate the reaction at RL and RR. So for us to calculate the reaction RL and RR, we need a watch or a circle. So here this arrow represents clockwise, and then this one, the upper one, represents anti-clockwise movement. So when we begin 4.1, take moment about RL. When we take moments about RL, we're calculating RR and all the forces needed RL again. So all forces meet at RL. We are calculating RR. So RR to RL, what is the distance? Again, all the forces are meeting at RL. So from RR to RL, we have 1, 2, which is 3, plus 4, plus 1, given by 8. So it's RR times 8. After writing down RR times 8, we need to check whether RR is going clockwise or anti-clockwise to RL again. So RR actually it is an upward force. And then it's a mass. So if this arrow is it clockwise or anti-clockwise? Anti-clockwise. Okay, let us check. 5 kilonewton, is it clockwise or anti-clockwise? Before we even calculate the RR and RL, we need to change the UDL again. So we have 7 kilonewton per meter. How do we change the UDL to a force? It's the UDL multiplied by the distance covered again. So the UDL multiplied by the distance covered. So our UDL is 7. What is the distance that the UDL is covered? 55. So 7 times 5? 45? 35. So it means our new force is 35. It's no longer a 7 kilonewton per meter. We no longer have a UDL, we have a force again. So after getting our force, we need to put our force in the middle again. So we have a distance of 5 that the UDL is covered. So 5 divided by 2 give like 2,5 again. And then more already 1. So 2,5 minus 1, shall I like? It means UDL like that we are more than more, we have a force 1,5, and then on the other side is 2,5 like 1. Okay. So we also need to change the other UDL here, 2,5 kilonewton per meter. How do we change the UDL to a force? It's the UDL multiplied by the distance covered. So our UDL is 2,5 kilonewton. What is the distance covered by the UDL? It is 1 plus 1,5 again. So it is 2,5. So 2,5 multiplied by 2,5 is like 6,25. It means now we no longer have a UDL of 2,5, we have a force of 6,25 again. So we need to put it in the middle. And the UDL is currently a distance of 2,5 like 1. So if we need to put it in the middle, 2,5 divided by 2 give like 1,25. 2,5 divided by 2 is equal to 1,25. So here are our new process is 5 needs to be in the middle again. And the more we have RR, which is 1,5. So 1,5 minus 1,25 gives like 0,25. So this side the distance you have the other side you have. Where is our force going to be? This side before RR or after RR? We cover after RR again. Reason being, linear DL of 2,5, we multiplied by the distance covered, which is 2,5. We have a new force of 6,25 again. So 6,25 here, we need to put it in the middle. So we found out that 2,5 divided by 2 for 1,25 again. And already more we have 1,5. We can't shift our RR again. So now we need to say 1,5 here minus 1,25 here. First year now, our new force that is replaced by the UDL, little by little more again. More like 0,0,25. So 0,25, okay, you have 0,25, and then side here, like 1,25, and then the other side 1,25 is like 0,25. Our UDL is like this, normally UDL, and then we have a distance here, 1, and then on the other side is 1,5 again. So UDL here, cover distance at 2,5. Here, cover distance at 2,5. We divide our 2,5 by 2, we got 1,25 again. More there's RR, and we can't shift our RR. So what we're going to do is we're going to take this 1,5 again. Then we subtract the 1,25 for the where is our force going to be. So 1,5 minus 1,25 is like 0,25. Now the first year like some more, and then more is 0,25, and then on the other side you like 1,25. So first year like it's in the middle now, you in the middle. So side here like and when you like 1 again. So we have 1 plus 0,25, give 1,25. First year like this is our force himo. So if our force is in the middle, 0,25 plus 1, I hit 2,5. Then the other side give 1,25 and I. First year like 6,25. More than 1 again. 1 more. And then this part is 0,25. Our first more again. This is our first. And then on the other side is 1,25. And then the distance from more, which are more, is 1,5. R move. Relay RR to RL, yet clockwise or anti-clockwise? RR to RL, yet clockwise or anti-clockwise? Anti-clockwise again. 6,25 here, is it going clockwise or anti-clockwise? 5. Okay, you're not supposed to look at 35 again. 35, is it going? 4. It means we no longer have first anti-clockwise again. The sum of anti-clockwise movement is equal to sum of the clockwise movement. So the total we have 6,25. So we have 6,25 multiplied by the distance covered from 6,25 until RL get like RL length 6,25 here, like each one 0,25 again. So that is 0,25 plus 1 plus 2 plus 4 plus 1 give like more first year and it's in the middle. Get 1,25 distance more again. So it's 1,25 plus 2 plus 4 plus 1 give like 8,25 is the first multiplied by the distance, and then plus 5. Give 5 times from 5 until I'll give like 2. 5 here more 2 like 1. So get 2 plus 4 plus 1. 5 times 7, and then plus 35 here again. So it's 35 times 2,5. Monkey 1, 35 here is here again. Here, so it's 1,5 here plus 1, so it's 2,5. Another first? 4 here and then times 1 again. So it's plus 4 times 1. So more you have 8 RR. What is 6,25 times 2,25? 6,25 times 8,25? 51,56 25. What is 5 times 7? 35. 35 times 2, comma 5. 35 times 2, comma 5. 87, comma 5. 4 times 1? 4. So here we have 8 RR. Let us get the sum of this. 35 by total. 178, comma 0625. Okay, so we have 178, comma 0625. We divide by 8 again. We divide by 8. So 8 cancels 8. RR 22,26 kilo Newton. It means our RR is 22,26 kilo Newton. And then now we're going to calculate RL again. When we calculate RL, it means we're going to take moments about RR again. Take moments about RR. What does this statement mean? All forces meet at RR. All forces meet at RR. It means we're calculating RL again. So RL multiplied by the distance from RL until RR. You guys? More 1 again. 1 plus 4 plus 2 plus 1 again. So give guys is 8. So RL times 8. So RL, is it going clockwise or anti-clockwise? 4, 35, and 5. 6,25 more again. 6,25. Here RL being clockwise or anti-clockwise? And then now we have 6,25, which is clockwise again. So it means K plus 6,25. What is the distance from 6,25 until RR? 0,25. So multiplied by 0,25. And then is there any other force that is going clockwise? So sum of the clockwise moment is equal to sum of anti-clockwise moment. So arrange 4 to RR, among distance. 4 here. Give 4 again. Plus 2 plus 1. Give like. Give 4 times 7 and then 35. For the UDL, remember the distance scheduling more fast. It's in scheduling more for them again. So 35, you have like 2,5 plus in plus 2 plus 1 again. Actually, we have 35. Here is our 35. So it's 2,5 plus 2 plus 1. What's the distance? So it's 35 times 5,5 plus more 5. So 5 to RR, it is 1. 5 times 1. Is there any other force? So it's 8 RN plus 1 is 6,25 times 0,25. 1,5625. 4 times 7. 28. 35 times 5, 5,5 here. 35 times 5,5. 192,5. 5 times 1. What is the total? Mogi 8 RL again. And then plus 1,5625. Total here, 225,5. And then we're going to take this one here, the other side, you jump a sign again. You jump the equal sign, so you have a minus. So it's 8 RL is equal to 225,5 minus 1,5625. We're not like 223,9375. So we need to divide by 8 both sides again. So divide by 8, divide by 8. This 8 cancels this one. So RR is equal to 27,99. So our RR is equal to 27,99. kilonewton. 4.2 banyak kan lagi? Question apa nih? Ekran. 4.2. Calculate and draw the shear force diagram. Insert all the values on the diagram. So shear force, we deal with forces only again. Shear force. Give 4.12. Shear force is equal to forces only. Shear force is equal to forces only. So Rotoma shear force at A. Shear force at A, what is it? 27.99. 27.99. So shear force, we are dealing with the forces that are acting on that letter, again on that reaction. So shear force at A, this is A. The force that is acting on A is RL, which is 27.99 again, and it's positive again, so it's up. But again, it's going upward, meaning it's positive. That's why it's having minus. So it means if more A, there was a force that is acting downwards, no problem, negative 27.99 again. And then shear force at A to B. Oh, it's not B, it's A to C again. You guys see here? This is C. So shear force at A to C is there a force? What is the force? Shear force at A to C, what is the force? Remember, shear force is again. So it's 27.99 and then minus 7 times 1. This 7 times 1 more. This is a UDL. This is a UDL, and the UDL is covered A to D again. So UDL here now more in between A and C. There's a UDL. Again, like when I can only UDL. So between A to C, there's a UDL. This UDL from A to C covers which distance? Yeah, 1 again. So it's 7 times 1. So you have what is shear force at A to C? 20.99. It's 20.99. Shear force. Who shall the shear force at my at C again? Shear force at C. There's a force that is acting on C by 1. So remember, we started at the beginning. So give guys 27.99 minus 7 times 1 minus 4. Are you multiplying us for it? Okay, it's forces only. There is a 7 times 1 here, you multiply us distance because it's a UDL again. So, okay, guys, positive 16.99. Okay, shear force at, we are done shear force at A, shear force at A to C, shear force at C. We are now going to shear force at C to D again. So shear force at C, this is C and then D. Shear force at C to D, roaring it. 27.99 minus 7 times 7 times 5. Why is it 7 times 5? We are looking for the shear force from C to D. So shear force at C to D, the UDL cover distance here plus 1 plus E plus 4 again. So it's 7 times 5 and then minus 4. If I let get up negative 11.01. And then now we have shear force at D. Is the force that is acting on D? You don't write skipper.
Yeah.
Yeah. Who knows shear force at D? So now we have shear force at you guys Kimo. Okay, shear force at E, as you can see, more E, there's a 5 kilonewton force